Alrighty, y'all. Today we're taking a look at question 1 and question 4 for Recitation 23. And for this one, we're trying to find the current through the wire, given that the magnetic field is 7.14 microteslas, 69.6 centimeters away from the wire, right? So our magnetic field, 7.14 microteslas, which always into base units, 7.14 times 10 to the negative 6 regular teslas, right? And our radius, our distance from the wire, right, 69.6 centimeters. Again, always into base units, 0.696 meters, right? And then for a long, thin, straight wire, we're going to use the equation that B equals our mu naught I over 2 pi r, right? We're given R, we're given B, mu naught, 2, and pi are all constants. So we have one equation, one unknown, and we're going to real quick solve this equation for the current at I, right? So if we multiply both sides by 2 pi r and divide by mu naught, right, it's going to be I equals 2 pi r B over mu naught, right? Our mu naught, that's just 4 pi times 10 to the negative 7th, right? So when you put mu naught in the denominator and then the 2 pi on the top, it's going to cancel out, and this is just going to be RB over 2 times 10 to the negative 7th. And you evaluate that out with the given constants, and that's going to get you your answer in amperes. Right? Now for question 4, right, we're trying to find the current, we're trying to find the force per unit length between the two wires. Right? Our wires here, and they're both coming up out of the page. Right? So we have 31 milliamps in this top wire. Right? So our 31 milliamps, again, converted into our base units. That's going to be 0.031 regular amps. And our current through the bottom, 68 milliamps, which again, always in base units, 0.068 regular amps. And we're given an equation in the textbook, right? Our force between two wires is, well, it's force per unit length, sorry. We're given the equation for force per unit length, and we're solving for force per unit length, right? Force per length is just mu naught I1, I2 over 2 pi r, right? And all this is if we look at this chunk here, we just pull this out. That's just our magnetic field, right? That's just our B mu naught I1 over 2 pi r, right? That's the same equation that we just used up here. Right, so all this is, so our force equals BIL, right, where this is the magnetic field caused by one wire, and this is the current through the other wire, right? So if it's B1 and I2, right, because we have our 1 and 2, right? Either way, all that stuff aside, we're just going to use this equation here to solve it out, right? Because we're just solving for force per unit length between the two wires. So our radius is our distance directly between them. We have a right triangle. Here's our distance between it. Ooh, that's a straight line. Right? Since it's 3 centimeters on this side, 4 on this side, it's a 3, 4, 5 triangle. So it's going to be 5 centimeters. So our force per length is, again, our mu naught over 2 pi is going to simplify down into 2 times 10 to the negative 7th times our I1, which was, it doesn't matter which one's which, because, again, force on one is equal to the force on the other because of Newton's laws, right? So I1, I2, or I1, I2, it doesn't really matter. 0.031 and 0.068. Right, and that's all over what we just said was our R, which is 5 centimeters or 0.05 meters. Right, so evaluating this out is going to get you, it's going to get you your answer for this question. All right, well, I hope you found this video at least a little bit helpful. Let me know if you have any more questions about either of these problems or any other problems you want me to try to explain, and I'll do my best to explain them because I guess Sydney explains stuff.